This next one says, we define X as a year between 2008 and 2013, and Y as the number of smartphones sold that year. We have our table, and so we have a couple questions to answer. Is Y a function of X? Explain why or why not. That's actually being asked down in C. So in the meantime, it's just asking, we have to answer A, B, C. How many smartphones were sold in 2009? So this is just, can you read our table? So 2009, it was not 17.3 smartphones. Look at your labels in millions. So 17.3 million smartphones were sold. Then it asks, in which year were 90 million sold? So here's 90 million. It was the year 2011. And then, is it a function, why or why not? Remember, for a function, each input has one output. All of these values are different. So whether you're looking, is y a function of x or is x a function of y, no matter which way you read this, it's a function because every value in this entire table is different. And so, yes, it's a function, and it's because of the definition of a function. Because each input has exactly one output. That's the definition of what is a function, and that's why this table would be a function. Our next one is sketching a graph to represent a situation that's happening. So let's read through our story. We'll highlight the parts as they happen. Scott leaves home at 12 o'clock and walks to the bus stop at a constant rate. Halfway there, he realizes he forgot his wallet, so he jogs back home to get it. Then he jogs back to the bus stop. It's 15 minutes to get to the mall. He shopped for an hour, and then he takes the bus back home. So when we think about drawing this, we're talking about two different things here. It's a function of time, and it's his distance from home as time passes that we're trying to explore. So if he leaves at noon and he walks at a constant rate, here's him in his home, and he's going to walk at a constant rate. So this is the first part, or part A. As we walk pretty slow, we're going to take quite a bit of time to go over a distance. Then halfway there, so we didn't quite make it to the bus stop. So if this is halfway to the bus stop should be about here is where our bus stop is. He realized he forgot his wallet, so he jogged home. Jogging home is going to go faster than walking. So let's make him go home a little faster, so a little bit steeper line. So that's the second part, part B. He jogs back to the bus stop. So at the same rate he jogged home, he's going to jog back to that bus stop. But remember, he goes all the way to the bus stop this time. Now he rides a bus, so he's going to go pretty dang fast for 15 minutes to get to the mall. So his time passing is not going to be quite as long as his time to get to that bus stop. And he's going to go fast because he's on a bus. He shops at the mall for an hour. Remember, when we're at the mall, we're not moving away from home at all. And so also think about timing-wise. Here, the bus ride from here to here, that's 15 minutes. He's at the mall for 1 hour, so that would be 60 minutes. So making sure that the timing is about consistent as well. And then takes the bus all the way home. For some reason, the bus does drop him at his house, so he's going to take that fast bus all the way back to his house. Then it just simply asks, is this a function? And yes, because it passes our vertical line test. Remember, drawing that line, does it hit the graph in one spot every time? Our next problem is tracking rainfall and then answering the question. So we have our weeks and we have our rainfall. So it first asks, what is the domain? Remember, we have X and Y in a table. Domain is always our X values. So when you don't have a lot of numbers, you could simply list them in your curly brackets. 1, 2, 3, 4, 5. We like them in numerical order. Or if you would have a wide range, it's X such that, so all values of X such that it's between the numbers 1 and 5. And it includes those values as well. This is a fancier notation used if you have a lot of values. What is our range? Remember, those are our Y values. So we have 1, 2, 3, 4. 1, 2, 3, and 4. If we wanted to write it in the fancy notation, it'd be all Y values such that it's between 1 and 4. When is our data increasing? So looking at our rainfall, it increases